Good morning, students. In today's class, we are going to discuss electric field due to uniformly charged infinite sheet. Uniformly charged infinite sheet. Electric field due to uniformly charged sheet. Uniformly charged sheet. Sheet, I mean to say, just like a paper sheet. Like a paper sheet, very thin sheet. Suppose it is a thin sheet. It is a thin sheet. And charge distributed over sheet is this. Just like, suppose like it is a sheet, okay, and this sheet is situated at this condition and this condition. Total charge distributed surrounding this and this. So we have to find electric field due to this uniformly charged sheet, okay. Let a point P, here it is a point P. We have to find electric field at point P due to this uniformly charged sheet. It's maybe infinite sheet, maybe infinite. This dotted line shows the infinity situation. It's also maybe infinity. And we have to find electric field at point P. This is the center point of this sheet. And we have to find electric field at this point. We assume the two small segments due to this sheet. Total charge on the sheet is small q. And suppose here is a segment, because charge distribution is uniform, that's why charge on this sheet is dq. And similarly, the same segment we have to take from the same distance at this center point. This is also dq. And both two distances are equal, means these two segments are same situation from the point. Then electric field due to this segment of charge at this point is in this direction. Here is test charge positive. So electric field acting in this direction dE. And this electric field is divided into two components. One component is this. This is the horizontal component and this is vertical component. This is theta angle, so it is dE cos theta and this is dE sin theta. Similarly, another electric field due to this segment is in this direction. dE. And also we have to divide this electric field into two components. One component is this and another is this, because this is theta. So dE sin theta and this is dE cos theta. This distance r is equal, this is also equal, and this is common distance. That's why these components are same. So they are acting in opposite direction, that's why they are cancelled to each other, and the resultant electric field is acting along this direction. So we can say electric field due to a uniformly charged sheet is always acting in the perpendicular direction of sheet. Yeah, or in another way we can say is always acting along their normal. Okay. And similarly, same situation is also drawn here. Suppose, okay, now the segment is this. DE, DE, this is theta. Finally, we can say electric field due to sheet is always acting in perpendicular direction, in this direction and in this direction. This is a perpendicular direction. Okay. So finally, we can draw Gauss surface, because we are studying here electric field due to uniformly charged sheet by using Gauss's law. So we can draw a closed Gaussian surface. Charge is positive. This is the observation point P. So we can draw a closed Gaussian surface. It is a cylindrical surface. These 2 points are there. Okay. And total charge surrounded by this Gaussian surface is Q, suppose. So electric field is acting in this direction and here is in this direction, and this is a closed surface. For Gauss's law, we have to consider one surface is this, another surface on the cylindrical part, and another surface is here. So suppose this is surface 1, it is surface 2, it is surface 3. In this, for the first surface, electric field acting in this direction and normal is also acting in this direction. So dA is in this direction. But for this surface, for cylindrical surface, normal is acting in this direction and electric field is acting in this direction. So there is angle between them is 90 degree. And here electric field is acting in this direction and area vector is acting in this direction. Okay. Now we have calculate electric field. Electric flux by mathematical form. Net electric flux phi is equals to E dot dA. For closed surface is this, and this closed surface is divided into 3 parts. 1, 2, 3. So we can write here for S1 surface E dot dA, for S2 surface E dot dA, and for S3 surface E dot dA. Okay. So observe here, in this case for S1 surface, E and A are acting in same direction, that's why the angle between them is 0. So it is equals to E into dA, because EDA equals to EDA cos theta and theta equals to 0. So cos 0 equals to 1. So we can put here EDA for this S1 surface. For this case, angle is 90 degree, that's why it is equals to 0. Theta is 90 degree, so cos 90 is 0. And in this case, again theta is 0 degree, so it is equals to E dot dA. This is for S3 surface. And here, S1 surface is equals to S3 surface S1 EDA plus This is also equals to S1 equals to S3 surface. So we can write S1 equals to S3. So we have 2 S1 or is equals to 2 EDA. Right? Because S1 surface is equals to S3 surface. Further we can calculate 2 E electric field is constant, integration of dA, S1 is equals to S3. Right? And now we have to take integration of dA, S1 is equals to S3 is equals to A. So flux emitting by the whole closed Gaussian surface is equals to EDA 2EA. This is equation number 1. According to Gauss law, Gauss's law, net emitting flux phi is equals to total charge enclosed by the surface upon ellipse naught, and total charge enclosed by the surface is Q. So this is equation number 2. By the comparing of equation 1 and 2 from equation 1 and 2, we get 2E into A is equals to Q upon ellipse naught. So E is equals to Q upon twice ellipse naught A. Here Q by A is equals to surface charge density. So the formula is equals to E sigma upon twice ellipse naught. Now in this case, and the vector notation of this case is sigma upon twice ellipse naught n cap. Electric field is independent of distance. There is no distance in this formula. That's why we can say electric field due to uniformly charged infinite sheet or sheet. Electric field here, at every point electric field is same. That's why sheets are used to provide uniform electric field. This is the derivation of electric field due to uniformly charged sheet. And now next topic is electric field. So graph of electric field and R can be drawn by ER, and here is electric field and the graph is this. This is R, this is E. Electric field is constant at every point from the sheet. And next topic is electric field due to uniformly charged plate. Uniformly charged plate. For plate, what is the meaning of plate? So I can explain here. Suppose this is a uniformly charged sheet. It is a sheet only, and there are so many sheets are made, and it form the plate just like this. It is from a plate. This is the thickness of plate, right? And it is a metallic plate. So we draw electric field. We draw the diagram of this by using this formula. You can plot here. One line is here and another line is here. Okay. That's why I can form it a very enlarged form. This is the two conditions. And we draw total charge situated outside the surface. So we can draw electric field Gaussian surface in this case, in this direction. This is the closed Gaussian surface, and we are taking one surface is here, another surface is here, and one surface is here. Okay, so electric field as this S1 surface in this direction, normal is also acting in this direction. This is surface 2, normal in this direction, dA, and electric field in this case, and here this is surface 3, and there is no electric field because electric field inside the metal is always 0. This is for plate. So electric field due to uniformly charged plate can be given by this mathematical formula. Okay, and here this for S1 surface, this is E dot dA, because theta is 0, cos 0 equals to 1, and for S2 surface is 0, and for S3 surface electric field also 0, because there is no electric field. So E dot dA, 0 multiplied by area is 0, that's why electric field in this case is also 0. Okay, and then we can say E dot dA, so here is only EDA, only for S1 surface. So we can find here is equals to E dot ds. So here is equals to A. And now 2 is removed from here. This according to Gauss law, this the expression is same from the equation 1 and 2 is also same, but here by the comparing of equation 1 and 2 we get EA is equals to Q upon L epsilon naught. So E equals to Q upon A L epsilon naught. So Q by A equals to sigma upon L epsilon naught. Right? So we can prove here E equals to sigma upon L epsilon naught. The formula is vector form is E equals to sigma upon L epsilon naught, and the graph is also in this manner because in due to electric field. Due to uniformly charged plate is sigma upon L epsilon naught. It is also independent of R. Right? Today's class we are discussing electric field due to uniformly charged sheet. The formula is uniformly charged sheet is E equals to sigma upon twice L epsilon naught, and electric field due to uniformly charged plate sigma E equals to sigma upon L epsilon naught. These both derivations is applicable for finite sheet or infinite sheet, same. Finite plate or infinite plate, same. Right? Okay. And for today's class, this is over. And in next class, we are going to discuss electric field due to uniformly charged straight conductor or straight wire. For today's class is over. Till then, bye bye.